Hello, so let's move ahead with chapter 5 of class 10, that is periodic classification of elements. Without elements, our chemistry is incomplete because everything in chemistry is about elements and its reaction. So let's move ahead with this. It is a very interesting chapter. Why is classification of elements necessary? So there was a difficulty in organizing all the known elements and the newly discovered elements. So scientists started looking for some pattern in their properties on the basis of which one could study such a large number of elements with ease. So there were a lot of elements that were getting discovered and it was necessary for them to be arranged into a table through that we can predict that what will be the reaction of that particular element with the other element. It helped us to relate these elements, okay, with each other. So in order to organize them, a lot of scientists came with different theories which were contradicted by the newly came theories, because chemistry is all about the contradictory that is discovered time to time. Okay. So it was very important to place them in order to get an idea of what kind of reaction this particular element can give in a chemical reaction. Okay, so these are the newly discovered elements here. Latest elements discovered such as nihonium, flavorium, moscovium, livermorium, tennessine and oganesson. So these are the elements that are newly discovered, and these some of them this and this. Okay, these four are named on the basis of a place where they discovered. Okay, but this oganesson is based on a nuclear physicist. Okay, on the behalf of his name, this element was named. So extra attempts of classification. So at first these chemical elements were divided into only two, metals and non-metals, but it was not sufficient to uh, you know separate them on the basis of their properties. So these are the elements that were discovered so far at that time. So Dobereiner's tried to arrange the element with similar properties into groups. He identified some groups having three elements each, so he called these groups triads. So these are the triads that he made in a group, and through that he concluded that this middle element is average of the adjacent two. Okay. So Dobereiner showed that when the three elements in a triad were written in order of increasing atomic masses, the atomic mass of the middle element was roughly the average of the atomic mass of the other two elements. It was very interesting, so he decided to go on with it. Suppose you take this group 4B for as an example. So this is calcium having 40.1 and 137.3 is this. The average is, so in order in this is average, okay, so it comes as, which is similar to, and this is strontium. Okay, so this is how he was able to get these elements into groups, but there were some limitations. Okay, so the limitation of it was that it was groups, okay, triads, but it didn't suffice the necessity of the other groups. There were only five groups that he was able to make, but he couldn't get all the elements into one place, and the newly came elements couldn't get into that classification. So it was contradicted by a new scientist that you'll see just in a minute, that music notes and octaves. In the Indian system of music, there are seven musical notes that are sa, re, ga, ma, pa, dha, ni. You all must be knowing that. And in the West, there are some other notations like this. So every eight note is similar to that of the first one, and it is the first note of the second scale. So through this motivation, through this idea, Newland's law of octaves was discovered here. So Newlands arranged them arrange the known elements in the order of increasing atomic masses. Okay, so he started with the element having the lowest atomic mass and ended at thorium, which was the 56th element. Okay, this you need to remember. He found that every 8 element has properties similar to that of the first one. So he compared this to the octaves found in the music. So this was the inspiration behind what he discovered. Okay, so in Newland's octave, the property of lithium and sodium are found to be same as that of Dobereiner. Dobereiner also considered lithium, potassium, and sodium into one triad because the average of the middle was equal. It was almost equal to that of the middle element that was present over that. So this was some similarity between them. The drawback of the Newland's law of octave. It was found that the law of octaves was applicable only up to calcium. Calcium has atomic mass 40. So as after calcium, every 8 element did not possess similarities, possess similar to the that of first. The assumption was made by Newlands that only 56 elements existed in nature and no more elements would be discovered in future. This was the major drawback of the Newlands, that not being able to get all those elements into, to have this eagerness of getting all these elements into one place led to the mistake that he didn't leave any places for the newly discovered elements. Okay, so in order to fit elements into his table, Newlands adjusted two elements in the same slot but also put some unlike elements under the same note. So Newland's law of octaves worked well with the lighter elements only, but not with the heavier elements that were discovered later on. So did Dobereiner's triad also exist in the column of Newland's octave? Yes. Lithium, sodium, potassium in the second group. It was there. So what were the limitations of Dobereiner's classification? That you need know that because of the newly discovered elements. Okay, then only 5 triads were discovered so far. Okay. So what were the limitation of Newland's law of octave? Because it couldn't fit the newly discovered elements. So this was the major drawback of it, and only up to 40 he was able to arrange them into a proper table, but it was not sufficient. So let's get into Mendeleev's periodic table.
By 1869, Mendeleev had been trying to find a pattern to the elements for a decade. Whatever order he and the world's chemists tried to impose, there were still elements that wouldn't fit. A universal theory seemed out of reach. But now Mendeleev hit on a new idea. He made up a pack of cards and wrote an element and its atomic weight on each one.
Strange though this might sound, so began the most memorable card game in the history of science. He called it Chemical Solitaire and began laying out the cards just to see whether there was a pattern, whether it all fitted together. Now, previously, chemists had grouped the elements in one of two ways, either by their properties, like those that react very strongly with water, or by grouping them by their atomic weight, which is what Berzelius and Cannizzaro had done. Mendeleev's great genius was to combine those two methods together.
The odds were stacked against him. Little more than half the elements we now know about had been discovered. So he was playing with an incomplete deck of cards.
He stayed up for 3 days and 3 nights without any sleep, just thinking solidly about the problem. Then on the 17th of February, with a snowstorm raging outside, he decided to stay at home. He was exhausted, and he finally dozed off.
The story goes he had an extraordinary dream. He saw almost all of the 63 known elements arrayed in a grand table which related them together.
It was an incredible breakthrough. I can imagine Mendeleev feeling like so many other scientific pioneers. It's that determination, even desperation to crack a puzzle, and then that eureka moment of revelation.
Mendeleev had revealed a deep truth about the nature of our world, that there is a numerical pattern underlying the structure of matter.
This is the periodic table as we know it today, and it's rooted in Mendeleev's discovery. It decodes and makes sense of the building blocks of the whole world. Now, although it's so familiar to us, it's on the wall of every chemistry lab in every school in the world. If you really look at it, it's actually awe-inspiring.
What's so remarkable is that it reveals the relationships between each and every element in order. Mendeleev had brilliantly combined elements' atomic weights and properties into one universal understanding of all the elements.
So the elements were arranged on the basis of their fundamental property, their atomic mass, and also on the similarity of the chemical properties. So Mendeleev concentrated on the four compounds formed by elements with oxygen and hydrogen. He selected hydrogen and oxygen as they were very reactive and formed compounds with most elements. That is why he chose hydrogen and oxygen. So increasing atomic masses, 63 known elements, he observed that most of the elements got a place in a periodic table and were arranged in the order of their increasing atomic masses. So it was also observed that there occurs a periodic recurrence of the elements with similar physical and chemical properties. So as you arrange them on the basis of their increasing atomic masses, then there is a chance to have the repeated elements with same physical and chemical properties. So that is why the placing has been taken successfully, because some of the elements relate to each other, but there are many more stuffs like because not having same type of atomic number, not having same number of electrons and electrons that are present. Okay. So, groups and periods, Mendeleev formulated a periodic law which states that the property of elements are the periodic function of their atomic mass. I'll put 3 star because it's just very important for the exam point of view. So, Mendeleev's periodic table contains a vertical column called group and horizontal rows called periods. So, this was the ultimate periodic table that he imagined to fill. Okay. So Mendeleev left some gaps in the periodic table. That was the boon for the other scientists, because it also challenged the other scientists to discover new elements, and also this made Mendeleev being more discovered and respected than Newland and Dobringer's trials. So Mendeleev boldly predicted the existence of some elements that had not been discovered at that time. Mendeleev named them by prefixing a Sanskrit numeral eka to the name of the preceding elements into the same group. Okay. So prediction of unknown elements' existence. So elements like scandium, gallium, and germanium discovered later have properties similar to eka boron, eka aluminum, eka silicon. Okay, so these both have the same atomic mass, same formula of oxide, same formula of fluoride. Okay, so prediction the existence of noble gas. Noble gas was discovered very lately because they are inert and unreactive, present in extremely low concentration in our atmosphere. One of the strengths of Mendeleev's periodic table was that when these gases were discovered, they could be placed in a new group without disturbing the existing order. So this was the boon for Mendeleev to have this periodic table because it left some space for the newly discovered elements. But there were also some limitations of Mendeleev's periodic table that no fixed position was can be given to hydrogen in the periodic table. Periodic configuration of hydrogen resembles that all of alkali metals and halogens. Isotopes of all elements posed a challenge to Mendeleev's periodic law. Isotopes of an element have similar chemical properties but different atomic mass. Okay, isotope was discovered far after the Mendeleev's periodic law was being discovered. So atomic mass do not increase in a regular manner in going from one element to the next. So it was not possible to predict how many elements could be discovered between two elements, especially when we consider the heavier elements, because when heavier elements were getting discovered, then they couldn't place them into a right place in the Mendeleev's in the it was not possible to predict how many elements could be discovered between. Okay, so heavier elements, because of heavier elements, periodic table is increasing. Okay, and it supports the Mendeleev's idea. Evolution of periodic table. So there is Dobereiner's, Newland's, Mendeleev. So group the elements into triads, law of octaves, arrange the element in increasing order of their atomic mass and according to their chemical properties. Okay. So use Mendeleev's periodic table to predict the formula of the oxides of the following elements. So at first you need to get what are where these groups are present. So K has first group, C has fourth group, aluminium has 3, silicon has 4, barium has 2. So through this you will be able to get to know what is the valence electron that is present. So K has only 1, oxygen has 2. You can do this and it is K2O. Likewise you can try it here. Okay. Besides gallium, which other element have since been discovered that were left by Mendeleev in periodic table? Any two. It was um, germanium. Sorry. Germanium and scandium. These are the two elements that were found way back after. Okay. So what were the criteria used by the Mendeleev in creating his periodic table was on the basis of groups and rows. Okay, so these are the criteria, and groups and rows are, we mean to see that it is horizontal and vertical. Okay, so why do you think the noble gases are placed in a separate group? Because it is highly unreactive, found in a very less manner, found in a very low, like noble gases are found in a very low quantity. Okay, unreactive. Alright,